Hello all. In this lecture, we are going to discuss on Pandas series data. Let us move forward to discuss the agenda. In agenda, first we discuss on why we need Pandas, introduction to data structure, how we can create series data structure from ndarray or list, then from dictionary, then from scalar value. Then we are going to discuss how we can use slicing in series. Then accessing a value in series data. Then we'll see how we can use various vector operation with series data. Finally, we'll discuss how we can include name attribute in series data. Let's move forward to discuss why we need pandas. When working with tabular data, such as data stored in spreadsheet or database, Pandas is the right tool for you. Pandas will help you to explore, clean the data, and process the data. In Pandas, data table is called a data frame. We'll move to discuss introduction to data structure. To get started, import NumPy and load Pandas into your workspace. To do this, we are going to use the keyword called import. So we use import as a keyword which will import both NumPy and Pandas to your workspace. So use the given statement here. Import NumPy as NP. Here NP is a alias. Similarly, PD is a alias for Pandas. Three main data structures are present in Pandas. One is Panda series, which is a one-dimensional array. Then Panda data frame, which is a two-dimensional array. Then Panda panel, which is a 3D. And now in this lecture, we move to discuss first one, Panda series. Panda series is a one-dimensional label array capable of holding any data type. Data type may be it's an integer, or it may be a complex number, or it may be floating point number, or it may be string, or any data type like a list, dictionary, etc. The access label are collectively referred to as index. The basic syntax to create a series data type is given here. S equal to pd dot series of data comma index. Here first argument data and second argument index. Here data and index are the parameter which is passed in the built-in function series. So series is a built-in function present in the tool Panda PD. This right side part which is called as data or value. This data or value which is assigned to S. Here S is called identifier or it is a variable name. Here data can be many different things. It may be an ND array or it may be a Python dictionary or it may be a scalar value. Scalar value is like a integer number or it may be a discrete number or it may be floating point number. The pass index is a list of axis label. Thus, this separates into a few cases depending on what data is. Now, let us move forward how we can create series data using ND array or Python list. If data is an ND array, index must be the same length as data. Now, to understand the concept of creating series data using ND array or list, let us consider a small piece of code given below. So, first initially we have to import both NumPy and Panda here. Then, to create a series data from ND array or list, first we need a ndarray or basic list. So we have to use numpy. So let's consider this statement here. On the right hand side of this statement, we have np.random.randn. We are using the function here called random, which is used to generate some random values. Let us consider here in this statement, I am using the random value as 6. So this function random from numpy, it will create 6 random value. So 6 random value will be assigned to a variable called data here. Finally, print the data. So here you see this data which contain 6 random value given here. We can cross check the same with Jupyter. So let's open the Jupyter. So the first foremost point is we have to import numpy as np. Then we have to import panda as pd. So the third statement, I have to going to generate ndarray or list. So let us consider numpy. From numpy, I'm going to use random dot rand in. So here I'm going to create 6 random variables. Let's consider. So the right side part has to be assigned to some variable. Let's consider data is my variable, right? You see here, right side part data. I'm going to generate some random values from random function. Then in the next statement, let's print data. And many students will ask, already in Jupyter we have a inbuilt function called print. Okay, why we are using separately? You see here, from beginner point of view, I'm using Jupyter as the IDE to learn the programming. But when you go for real life world, real life problem, as a developer or a programmer or data analyst, we have to use a decent IDE like a Python or a Spider, which is quite, or we can use Visual Studio. So these are the IDEs which are people are using in real life industry for programming. So to have the point, I'm using a directly print of data. Now let's execute the statement. Yeah, good. So here this statement, it will generate 6 random values. So the first step is completed. And now I'm going to generate, or I'm going to create the series data structure from numpy random value. Here you see already I have created random values. So now I'm going to create series data. So in Pandas we have a function called series, pd.series, which is having a structure called data comma index. Here data and index are the two parameter which is passed in series function. So here already I have generated or created the data with 6 values, and for each 6 values I need to create a label. So how I can create a label? Using a index as a parameter. So here I am passing the index, which is a list here. So it's a list of 6, is a list of 6 elements or 6 values. So each of these labels will be mapped to the data. So when I execute this command, the interpreter, it will generate the series data structure with this format. So let us assume label A with data minus 0.404. Let us consider for B minus 1.615, for C minus 0.076. Similarly for F, we have 0.65196. So this is the way we can create series data structure using ndarray or list. So after executing this statement, we can get the output like this form. And we can check the same with Jupyter. So here you see I have created data. The next step I'm going to create a series data from Pandas. So this series built-in function which is having two parameters. One is data, comma, then index. So index equal to, it's a list where we can provide labels. So let us consider A, comma, B, C, comma, D, comma, E, comma, F. Fine. So this entire value has to be assigned to some variable. Let's say I am going to use variable called S. Then print yes. Okay. Let's execute this statement. Yes, good. So after executing, I can generate a series data from a list or ndarray from np.random. And you see the data type is float 64. I hope so this concept could be clear. And now let's move forward to discuss. Let us consider a situation. If no index is passed, one will be created having values 0, 1, 2, 3 up to length data of -1. So let us consider while creating series data, I am not going to pass index as a parameter in the series. Okay, so in this case, if we consider how data will be created with corresponding label. So in this case, the interpreter itself, it will generate the indexing like 0, 1, 2, 3, 4. So how we are getting these values as a label? So here you see, I am given random value of 5 here. So I am going to create 5 random values using random function. So for 5 values, let's take this n equal to 5 or data equal to 5. So for 5 elements, so the corresponding label will be, it can be generated from 0, 1, 2 up to, what's the length of data is 5. So 5 minus 1, 4. So we'll have index 1, 0, 1, 2, 3, 4. Okay. So for indexing 0, I'm having some random value 1.54. The next indexing 1, I'm having data 0.04. Similarly for 2, 3, 4. And we can check the same with Jupyter. So let us consider. Let us copy. So here I'm going to create a pd.series of np.random.random of 5. So here you see here index is not specified. Okay, so let's execute the step. Yes, good. So here, without specifying index, I can generate the series data frame. So I hope so this could be clear. And now let's move forward to discuss the next method, how we can generate the series data. So in the second method, I can generate series data from Python dictionary. And let us consider a small piece of code given below to understand the concept how we can generate series data from dictionary. So let us consider here this small piece of code. Here I'm going to take a dictionary as the input data. So let's take a dictionary. Here in the dictionary D, which consists of 3 pairs with BB is a key and corresponding value is 10. Similarly for second pair of data and third pair of data. Here the series data can be created directly from the dictionary. So once if interpreter execute this statement, then interpreter will generate the series data with label BB with value 10, for AA 50, and for label CC the corresponding data is 20. You see from dictionary, as you know, it's a pair of both key and value. So while creating series data, the keys will be the label and your values will be the data in series data structure. So once if you execute, I can get the series data like this. Okay, we can also cross check the same with Jupyter. So let us use the both number and panda here, and let's consider a dictionary D equal to, let us consider some value like a BB, and corresponding data will be 10, comma A, corresponding value will be 50, comma CC, and corresponding data will be 30. So here I'm going to create a series data from dictionary D. Yes, fine. Now let's execute. Yeah. So here you see the keys and the corresponding value. So using the dictionary, I can create a series data structure. So I hope so this concept could be clear. And now let's move forward. Suppose assume that if an index is passed, the value in data corresponding to the label in the index will be pulled out. And to understand this idea and concept, let us consider this piece of code, the same example. Here you see we have taken the dictionary, the previous example D. So here I'm going to pass index. So when I pass index in this example, so how the interpreter it will generate the series data structure. So here you see the index, in the index I'm passing some elements as a list. So each of these elements, I mean the values in data corresponding to the labels in the index will be pulled out. So here you see for index BB in dictionary, you see the key will be BB and corresponding value will be 10. So here the value will be determined based on the key. So you see in index we have the labels BB. So for BB the corresponding value in series data structure is 10. The next label will be CC and corresponding value will be 20. The next label is DD. In dictionary, we don't have any key. So for this label DD, the value will be NaN. NaN stands for not a number. Then the label AA. For AA, what's the corresponding data? 50. So you see here in this case, if index is passed in the series as the parameter, how the interpreter will determine the series data? So it is based on the corresponding key. Okay. So when I execute this statement, I can get the output like this. Yes, here we go. So we can get the same output here, but you see the data are present in the data type as float. Okay, we can cross check the same with Jupyter. Let us copy this statement in the previous example. So here I'm going to create a series data. So here the data is d comma, I will pass index. So index equal to, let us consider the index value. Let's say I have to use bb comma, let's see cc comma dd comma aa. Yes, fine. Now I can assign this entire expression to some variable called x equal to. Okay. Now let's print of x. Okay. Yes, is good. Now I have created the data series data by passing the index. Clear? So I hope so the concept could be clear. And also you see I have checked what is the address. You can check the address of any data using id function, which is a built-in function. So id of, let's say here the series data will be present in variable x. So let's execute. So here id of x. Yes, we got it. So here I can get the address where this series data is present. Okay. I hope so this concept could be clear. And now let's move forward to discuss the next method, how I can create series data using scalar value. Before to that, we can understand what is NaN. NaN stands for a not a number, which is a standard missing data marker used in Pandas. So make a note of this point. So now I can discuss how we can generate series data from scalar value. So if data is a scalar value, an index must be provided. The value will be repeated to match the length of index. To understand the concept, let's consider the piece of code given below. So here, let's consider both the package, import both of the package. Here I'm going to create a series data from scalar value. Let's consider 50 is my scalar value. Here I have to provide index. Let's consider in this index, which is in which we have 5 elements in list. So let's see the first element A. So A is the label and corresponding data will be 50. The next B is the label with corresponding data is 50. Similarly for next element C in index and corresponding data is 50. Similarly for D and So this is a way we can create series data structure using scalar value. So once if you execute, I can get output like this. Also, we can check the same with Jupyter. So let's copy, and now I'm going to generate series from Panda. Fine. Let's pass scalar value. Let's consider 50, comma. Then I can pass index equal to, let's see, value will be, okay. So let's say here I am going to use this index value with 4 values, and let's execute. Yes, good. So here I have generated or created series data using this scalar value. So here index, which is having 4 label. So for each of these label, the data will be 50. BB 50, label CC 50, label 50 is 50, label AA is 50. Clear? I hope so this concept could be clear. Already I said, what's a scalar value? So scalar value may be a floating point number or integer, or it may be discrete value or enumerated values. I hope so this concept could be clear. Now let us move forward to discuss how we can use slicing operation in series data. So slicing operation in series is similar to ndarray. And now to understand this concept, let us consider the small piece of code given below. So here let's consider we have a dictionary with data, a variable name d equal to. Let's consider a dictionary here. And here we are going to create a series with this statement using Python dictionary. And now let us consider this statement, which will generate the output as label BB and corresponding value is 1. Then for CC corresponding value is 2. For DD the value will be NAN, and for AA value will be 0. And now let's see how we can use slicing operation. Here suppose assume that print x of 0. So this statement, when interpreter execute this statement, you see if I want to access any value, let's say label BB, and what is the indexing position of this label? It's 0. Similarly 1, 2, 3. So when interpreter execute this statement print of x of 0, in indexing position 1 we have data 1. So when interpreter executes, I can get the output as this given below. So here you see when interpreter execute print x of 0, I can get output as 1, which is a floating point data. Clear? Similarly, when I'm going to use slicing here, print x of beginning value is not given here, but ending value is given here. So in the slicing operator, x of colon 2 here, let's consider the slicing operator, it will return up to n minus 1 value. Here in this case n equal to 2. So the slicer it will return the values from 0, 1. So it will return only 0 and 1 value. So you see here in indexing 0 I am having a label BB and corresponding data is 1. In indexing 1 I have a label CC with the data 2. So when interpreter execute this statement print of x of colon 2, then I can get output like this. Clear? Similarly, when interpreter execute print of x of 2 comma 0. So in indexing position 2, I have the label 2 and corresponding data is NAN. So I can get DD label and corresponding data is NAN. Similarly for indexing position 0, I have label BB and corresponding data is 10. You got the point? And now let us check the same with the Jupyter. So I will consider the same previous example. Let's see. So let us consider this example. So I'm going to generate series data from dictionary here. Now let us use how I can access this data. So print x of 0. So it will return what is the data present in indexing 0. I mean the data is 10.0. Then x1 print of x of the slicer. Okay, I'm not providing beginning value but ending value I can provide. So this it will return the output as label BB and CC with corresponding data 10 and 30. And the last one print of x of 2 comma 0. Yeah, it's good. Hopes. So we have a key error here. So yeah, so we got the output here. Okay, so this statement it will return the output as DD and BB and corresponding value will be for DD label we have NAN, for BB label we have 10 data. Clear? I hope so this concept could be clear. And now let us move forward to discuss in series data. If we need the actual array in series, we can use this statement series.array. So to understand this concept, let us consider the following piece of code. Here, let's consider the previous example. Okay, in the previous example, we have created a series data using dictionary. Let's say, or let us consider, if we want to understand what is the actual array present in X, what does X denote? So what type of array present in X? So we can determine using series.array. So once if you execute this command, I can get the output like this. So here in this context, X denote it's a panda array which contain 4 elements here. Okay, what are the 4 elements here? BB data 1, CC 2, and DD will be NAN, and for AE data will be 0. So we have 4 elements as a list and length will be 4. And even we can check the same with, let us consider the same example here. Let's see x dot array. Okay, yeah, so here the series data x, which is a panda array which contains 4 data, length will be 4. So I hope so this would be clear. Now let us move forward how we can access any value in series data. A series is like a fixed size dictionary in that you can get set value using index label. To understand this concept, let us consider the following piece of code. So here you see I can generate or create series data, okay, using this statement. Let's see this statement, it will create a series data from this list. So suppose assume that if I want to determine or if I want to access any data in the series data structure, how I can use? I can use using label. So let's see, we have a data. Let's see what's the data present in, what are the elements present in data. Let's see, we can check with Jupyter. Yes, so you see in variable data we have this 6 random elements. Suppose we can directly check this statement with Jupyter. So here let us consider pd dot series. Then I can pass data comma index equal to. So already we have the index here. Let's see this 6 index. Yes, okay. And I can assign to this entire value to variable s equal to. Then I will print s. Yeah, I got the output here. Now let's see how I can access any element in series data. So this can be done using the label. Okay, let's see here. I want to access. Okay, what is the data present in B? So you see here, what is the data present in label B? 1.460630. So how I can access? I can access through the label. So S of B. Okay, B is the label. And now execute the statement. Yes. So I can access or get any value in the series data using the corresponding label. Got the point? Similarly, I can check whether any label is present in the series data or not using in operator. I mean membership operator. So as you know very well, what are the two membership operators are there? In and not in. So I can use in and not in. So let's say I want to check whether C is present in data S. Yes, you see here in series data, I have a label C. Now I will check a label which is not present in this series data. Let's see Z. So you see here this label Z is not present. If I check Z in S, so interpreter it will return false. Yes, correct. So you can access any data in series array using index label. So I hope so this concept could be clear. And now let's consider this condition if label is not contained. So if any label is not contained, your interpreter will throw an error. Let's see. Let us consider the same example. Let's see. I want to check print. Let's see print is of Z. You see label Z is not present. So if consider if any label is not present in index, so your interpreter it will throw the error. What type of error? It's a key error. You got the point? I hope so this concept could be clear. See, also we can use a method called get method. So using get method, a missing label will return none or it will return some specified default values. So I'm going to use get method. Let's check with the Jupyter now. Okay. So here, let's see. I'm going to use the get method. So what's the variable of my series data? It's a yes. So yes dot get. I'm going to check label Z. So Z is label Z is not present. And when I execute the statement, you see here I will remove this statement. Yes. When I execute this statement, interpreter, it will return the output as none. Okay. Here it will not throw the error. It will return the output as none. Also, suppose assume that I'm going to specify some default value in the get function. Let's see, is a comma, and the default value will be, let's see, np dot nan, not a number. Okay. So here you see, when interpreter execute this statement, here you see I have provided some default value here. So when interpreter execute, in this case, for label not present in the index, your interpreter, it will not throw the error, or it will give the output as some default value NaN in this case. So I hope so this concept could be clear. So I will move forward to discuss the next concept on how we can use some vector operation with series. So to understand, let us consider this small piece of code given below. So let's consider here, let's take a previous example, and here I'm going to perform some addition operation with series. So when you see here, when interpreter execute this command, it will generate the output with this format. Okay, it's like an addition of two series, s plus s. We can directly check with the Jupyter. Let us consider the same previous example here. Here I'm going to perform vector operation plus s. So here you see what is the value of a is 1.97. Okay, when we had x plus s, for label a we can have a 3.9. Similarly for b, what is present in label b, we have 1.4, and when we add its data present in b, label is 2.9. Okay, just the addition of two series data. So you see here, when working with raw numpy array, looping through value by value is usually not necessary. The same is true when working with series in Panda. Series can also be passed into most numpy method expecting an empty array. So now let us move forward to discuss few more operations like multiplications. So it's quite simple when. So here in spite, okay, so directly I'm going to perform multiplication s into 3. So it will generate, you see here, in label A we have 1.9, and which is multiplied by 3 times, I can get data as 5.92 in label A. Similarly for rest of labels, okay, B, C, D, E, F. So I hope so this vector operation is clear, and the output for this multiplication is given here. So Panda series data can also be passed into most NumPy methods exporting an empty array. And here you see in this example, so Panda series can be passed in some NumPy method. So here the NumPy method is exponential. It's an example given here how we can pass a Panda series data into NumPy method. So when we execute this statement in Jupyter, let's see. Let's see here, numpy np dot exponent of the date series data is s, and execute the state. Here we go. So after executing this command, I can pass a series data array into numpy method exponential, I can get the output with exponential value. So I hope so this concept could be clear. And now let us move forward to discuss the last one, how we can include name attribute in series data. So here you see, let's consider the same previous example here. And here I can use or include name attribute in the series data. So just you can specify name attribute within the quotation as a string. And after executing, you can get output with the name attribute as Jasmine. So here name of the attribute is Jasmine. So in the same example, let's consider I'm going to specify name attribute. Let's see, name will be okay. Let's see, it is name will be Rose, and then I will print the series data. Yes, let's execute. Yeah, here we go. So here the interpreter it will return the name of the attribute. Okay, is Rose, which is written here. Clear? I also the concept is clear here, and you see the to understand the Pandas series, I have referred Pandas documentation by Wes McKinney. Okay, that's all about Pandas series data. Thank you so much. We'll see you in the next lecture.